This is question 8 on the second tutorial problem sheet, and the question is find V out using nodal analysis. Right, so there's V out. Now we've already got the nodes identified, A, B, C, D, and the first thing I'd do is just note that VA equals 15 volts, right? There's the reference node, there's node A, and the only thing between them really is the 15 volt supply. And the other thing you can see is the voltage at D is equal to, well, this is 0, that's the plus side, that's the minus side, so that is a drop of 10 volts. So VD is minus 10 volts. Right, now we need to do some thinking. So we have IR1, we have IR2, and let's make it go that way. We have IR3. The reason I'm making it go that way is because we've already got a plus sign and a minus sign, and I want to keep this guy satisfying the passive sign convention. And then let's do IR4 that way, and let's make IR5 go that way. And that's about all we need to do. So let's write out all the different currents. So IR1 is VA minus VB on 2700. IR2 is 0 minus VB on 3900. IR3 is, what is it? It is VB minus VC, also on 3900. IR4 is VD minus VC on 5600, and IR5 is 0 minus VD on 2700. Okay, so we already know what VA is, so we can rewrite that as 15 minus VB on 2700. And we can rewrite that one as minus VB on 3900. And we can't rewrite that one. We can rewrite that one. That one is VD is minus 10, so it's minus 10 minus VC on 5600. And this one is going to be IR5 is minus VD on 2700, which is minus 10 on 2700, so that's just 10 on 2700. Okay, now let's write the nodal equations, the KCL. So KCL at B is going to be IR1 plus IR2 minus IR3 equals 0. KCL at C is IR3 minus IS plus IR4 equals 0. And that's about all we can do. So we've got 4 nodes. We already know the voltages at A and D, so we only need 2 equations and 2 unknowns, so that should be enough. So that means we've got VA minus, well actually we already know what VA is. So that's 15 minus VB on 2700. That's IR1. IR2 is minus VB on 3900, right? Minus IR3 is minus VB plus VC on 3900, and that equals 0. Okay, so we've got minus 1 on 2700, minus 1 on 3900, minus 1 on 3900, and that's all VB, and we've got plus 1 on 3900 VC, and all of that equals minus 15 on 2700. Okay, and then the other equation, IR3 again. IR3 is VB minus VC on 3900 minus IS, which is 200 microamps, and plus IR4, which is so it's actually minus 10 plus VC on 5600, and all of that equals 0. So that means we've got 1 on 3900 VB plus minus 1 on 3900 plus minus, so minus 1 on 5600 VC, and that equals 200 plus 10 on 5600. Okay, so let's just save that, and I'll try and get a another screen so we can do that. So let's pull that up. There's MATLAB. So what we had in our so Q8A matrix, and I'm going to do the RF version. So it's going to be minus 1 on 2700, minus 1 on 3900, minus 1 on 3900, 1 on 3900, and then it's minus 15 on 2700, and then the other one is 1 on 3900, minus 1 on 3900, minus 1 on 5600, and then it's 200 by 10 to the minus 6 plus 10 on 5600. Okay, and then our answer will be so Q8 ants is going to be the RF of that, so Q8A, and it looks like we're getting a VB of 5.99 volts. So VB up here is 5.99. Let's try that again. So 5.99 volts, that's VB, and VC equals What did it say again? It said minus 1.034. So minus 1.034 volts. And that sort of makes sense given that we've got 15 volts here, we've got about 6 volts here, minus 1, minus 10. So it's sloping down that direction. That sort of makes sense. Okay, so that is the question 8 answer from today's tutorial.